we are going to create a working example of building an RPG application with a display file and using embedded SQL, some standard RPG things, and we are going to do it, basically write all that code locally and then compile it on the IBM but write the code locally. Now you may be wondering, well, why are we going to do this? And the reason that you would do this is because when you develop locally, just like you would in other ecosystems, you'd get the use of Git involved, and as well as the use of some pretty cool extensions that you can get for VS Code, which is very cool. And I'm going to share that with you. We're going to be using Make, of course, writing RPG, Visual Studio Code on my local machine, as you'll see in just a moment. Let's just go ahead and get started, I suppose. Of course, the very first thing I'm going to do is create a repository on GitHub. So pretty straightforward process, and I'm just going to call it RPGLE video, and I'll just write in the description. Oh, it already exists on this account. Let's call it something else. Demo. Excellent. So I'll just put in the description RPGLE video demo, and that will be our repository that we're going to use throughout the video. And of course, you'll be able to see it online afterwards as well. Following that, let's go ahead and open up a directory, or at least create a directory on or in our IBM on our local machine. We're not working on the IBM in this video. I'm going to go ahead and create a folder here on my MacBook, and this does also work on Windows, but I'm going to call it RPGLE video. And you can just have that open. That's going to be our directory that we're going to work in for this. And I'm going to go ahead and make an initial commit. So I'm going to make a readme.md, and I'm going to put in just some stuff in there as you would. And I'm going to make that commit. So first off, I'm going to initialize the repository on my local machine, and then I'm going to stage it and say init commit. And that's going to be on my local machine, but now we need to push that up onto GitHub. Now I have the terminal open here, and really all I'm going to do is copy the commands that Git is telling me to use. So it's pretty straightforward. Sorry, GitHub is telling me to use. So I'm going to copy that and paste it into my shell. So that just adds the origin, the remote address for the origin. Then I'm changing the branch to main, and then I'm pushing main to the origin, which is the GitHub URL, and now it's on GitHub. So from here we have pretty much everything that we need in order to write some code and use Git. But of course the next step is actually writing some RPG code. So there's a bit of setup that we need to do for that. We're going to do that together. The very first thing that we're going to do is go ahead and connect to an IBM. Now I already have a bunch set up, so I'm going to go ahead and connect to the one that I'm going to work with. And I think for this next piece, I'm just going to fix some settings. So I want to change the terminal size, I think. So I'm just going to search for that and change that font to be 15, just a little bit too big for me right now. But I'm also just going to zoom in a little bit, just so the video is a bit clearer. The very first thing that I need to do is tell VS Code where I want to deploy my workspace. And the workspace is the folder that I have open in the Explorer. So the RPGLE video folder that I made, that is the folder I want to deploy. But I need to tell Code for IBM where I want to deploy it. So really we just need to come over to the IFS browser. And I have one from yesterday that I was using, but I'm going to go ahead and create another one. So I'm going to create a directory in my working directory, which is /home/Alan3, and I'm going to name it RPGLE demo. So that went ahead and created it, and if I scroll down, I can see the folder right here. From here, I'm going to right click and say add IFS shortcut, and then it appears at the bottom, so I have a quick shortcut to it. And then the really important part right now is just telling VS Code that we want to deploy to that directory. So all we have to do is right click on it and say deploy workspace to directory. and that's it. And we can deploy now if we want to. I'm not going to because, again, it's just a README. I don't have any reason to deploy to it. I'm going to close that. Now that we have really all of the initial work done, I can have a sip of my tea. But now we can actually go ahead and create the base, what we need for our application. And the very first thing that we need is to tell VS Code how to basically build our application. Now in this, we are going to be using Make. You can use Bob also, which is a whole new thing that's going to be coming out soon. I'll probably be doing another video on moving away from Make and going to Bob, or perhaps just using Bob from scratch. I'm using Make in this because just for the sake of having the video, just makes things a bit easier for now, because it's easier to install. You can install Make from the Yum repository provided by IBM. So you should go and get that first, obviously, before we do any of this. Now, the very first thing that I'm going to do here in my workspace is create a new folder, and I'm going to call it .vscode. And inside of that, I'm going to create a file called actions.json. So this is really just the list of commands that can be run from this workspace. So of course you would check them into the repository, so then others that work with this repository will also have the same actions, which is really cool. Now there's also a schema for the actions. So as we type, you'll see that VS Code is making suggestions on what we should be typing. So for example, you can ignore Copilot there, but if I press a Control space, it is actually telling me the available properties for that schema. We'll start with name, because obviously I want one to do a deploy and a build. So I'm going to call it deploy and build. And I'm going to put a little emoji in there because emojis are cool. And then I'm going to give it some other values. So the environment is going to be in pace. I want the command to run in pace. Then there's also extensions. This will work for every file type. We won't worry about that for now. Deploy first is true, because I want to have the source code sent up to the server before I build anything. And then the command to run. So this is where we're going to specify the path to make. And that's pretty much, and of course any parameters that go along with it. So let's do one. Let's do /q opensys /packages /bin/gmake. That is the path to make that is installed through Yum, and that's what we're going to leave as. And then of course any optional parameters that you want. So I know that for the sake of this video, I know that we're going to have one called for binlib, which is the library that the objects will be built in, and we're going to have that as and curlib. Now we'll talk about curlib in just a second, but we're also going to do one more. We're just going to do a fake one. We're just going to call it ops equals * event f. Now let's talk about the command and why we have these options. The reason we put curlib with an ampersand here is actually because that's a code for IBM variable. So if we come over to the code for IBM extension and go to the user library list, there's actually a way that we can set the current library. So I have mine set to Barry right now. And so when this command is run, that is going to be Barry. So it's basically going what configuration I have set up in my environment. And then ops * event f really doesn't do anything. The reason we have event f in there is because that tells code for IBM to go out and fetch the error listing for the object that we're trying to compile. And if it wasn't there, the errors wouldn't show up. We want that to happen. So let's go ahead and save that. So really that's all that we need for actions right now. Next up is actually writing some code and deploying it. Now, of course, I don't want to spend this entire video writing code. So I did prepare most of the code ahead of this video just in order to speed things along. And you have access to the code also, which is important. So we're going to make some folders. We're going to make the generic kind of, IBM folders. First off, we'll make q/RPGLE source, and we'll follow that with q/RPGLE ref, and then we'll end with qdds source, because again, this application will have display files, so we need a folder to put those in. We're also going to make the makefile for now. It'll be blank, but we'll just have it there for when we need it. Now, of course, again, the source code is coming from somewhere else, so I have a different repository already prepared. And of course, I could have just cloned it, but I wanted to show you the setup that I did to get this to work. So I have this base repository that you can, of course, just clone and work with, but we'll just copy the source code basically directly from it. So I have two main files that I want. Let's just have a look at these. This is deps display file, so I'm going to copy that here and just make that in QDDS source. So deps.dspf, and I'm going to paste it in. And you can see here that the syntax highlighting is working as expected. That's excellent. Then I also have emps display file. So let's just take that, copy, and let's make that to emps.display file. Paste that in, looking great, looking good. Let's close that too. Then let's go back to QRPGLE ref. And inside of that, we have a constants, which really is just a bunch of constants. So let's just copy that and paste it in. But of course, we need to create that file. So I'm going to call it constants.rpgle. Paste it in. And of course, you can use any extension that you want for your prototypes. I know some people use RPGLE-H. I'm also aware that some people use RPGLE_H. It doesn't really matter. However you prefer it is fine. As you can see, I have it configured to work with both, but I'll just leave it as that for now. Then next up, the last two files that we need are going to be QRPGLE source, deps, and employees. The last two main files. So let's copy that and go over to here and create it. deps.SQL_RPGLE, I should have said. And of course, the last one, which is employees. Let's copy that, bring it on over. Drop it in, save it. Okay, so now we have all of the source code other than the makefile. But I would like to talk about our SQL RPGLE programs first of all. Let's start with deps because that's a good one to go with. So we have our header. We have a prototype to the employees program that we also have. We have a constants copybook. So this is actually bringing in the constants file from the that we have in our working directory, in our workspace. Then we have an fspec, an old styled fixed format fspec, which declares our deps display file. Then we have some variables, some workstation indicators, and we'll talk about these a bit later, even though the only one we really use, I think, is page up, page down. I think those are the important ones here. Then we have another one called file info, and we really only use funky from here. And then the rest of the work is really just reading from the table and of course writing it to the display file. And we read from the table using embedded SQL, so we have that in there as well. Really basic program. Then employees is pretty much the same program, but it is completely free format. It's a completely free format program. The fspec, everything, free format, easy peasy. I guess the next piece obviously is to bring in the makefile. So let's do that. And we'll talk about the makefile too. Let me copy it on over. Let me paste it in. Let's have a little chat about the makefile. So the makefile does a few things. The first three really set some variables for us. So here we have that bin_lib again, and this is just a variable to say that we want it to build in CMP sys by default. But you'll see that we override that in the action because we build into our current library. Then we have a setup for the lib list, where we're setting the build library to be on the library list as well as sample. Of course, you can add additional libraries on there if you chose to. Then we're setting the shell. Now we do this because we want to use QSH to run the commands, and we do this because we use liblist throughout execution in order to set the library list for the programs to be compiled correctly. Otherwise, they won't find our sample data and they won't find our display files, so on and so forth. And we really just append the library list in there. So And then we really have what is going to happen. So the OR specifies what objects are going to be built. So in this case, we have depths and employees, and they have a target of SQL RPGLE. So you can see down here, this target is defined %.SQL RPGLE, and these are the commands that it's going to run. And we have the same with the display files. But notice that the display files aren't written in the all part. They're actually defined as dependencies for these targets themselves. So deps.SQL depends on deps.displayFile, and the same with employees. It also depends on emps. So it's pretty basic makefile. Of course, it can be much more complex than this, but for the nature of this video, it's really simple. Doesn't do very much. Now, before I do anything further, I am going to make one more commit. I'm just going to say added source code. Of course, I didn't stage anything, and I'm going to push that up there. So then if we go back to GitHub and take a look at my repositories, you can see here that RPGLE demo, the repository that we created at the beginning of the video, now has all of the content in it 15 seconds ago. Excellent. So we're up to speed. We have everything that we need. We have our actions, and we have all of the source code that we need. And the next step really is to run the action and deploy it. So let's go ahead and do that. Now, of course, the easy way to start is to open some SQL RPGLE. And dependent if you're on Mac or Windows, you can press Control E or Command E. So if I press Command E, you can see here that I have deploy and build. Other action shows up from actions that I have defined in code for IBM, but I'm not particularly worried about that right now. So deploy and build is the one that we're going to be working with. If I run it now, it's going to ask me if I want to deploy all of the changes or the staged changes. So, you know, if you're already working on one source file or one file, you don't really want to have to upload everything again. You can just tell it to upload one file, you know, the staged file, or however many staged files you have. Anyway, if we click all, it's going to actually deploy everything. And so now if I come back to the IFS browser, it did compile the application, but we'll talk about that in just a moment. If we come back to RPGLE demo and I just click refresh, you can see here now that everything was actually uploaded to the remote directory as I expected, which is really cool. Now I would like to show you something else. So what I'm going to do is bring up the 5250 terminal here, put it on a new tab so we can have some space. There we go. Close that for a second. I'm just going to sign in, and I want to look at Barry, which is where I compiled my objects, remember, because I'm using curlib, and my current library as set in code for IBM is Barry. So there's all of the objects, but I'm just going to go ahead and delete all of those really, because I would like to show you that it creates all of these objects naturally on its own. And you can see here that the error listing did return some informational messages, very useful. Nonetheless, let's run it again. So if I press Command E, deploy and build, it wants to do all. So it's going to do the deployment, and then the action is running, and it says it was successful. Now, if we go back and take a look and I do a refresh, the objects are there. So we are writing code locally and building up on the remote. And now what I will do is show you that this is really a real thing. So I'm just going to create a different file. I'm going to call it hello vid, and I'm just going to get rid of all the content inside of it, and I'm just going to say not that. I'm just going to do a ctl opt dft at group no, star no, and I'm going to do a declare s, and I'll say text, and I'll make it character 52. You know where we're going with this. Text equals hello world, and then of course display text and return. Great. Now if I just quickly append hello vid.rpgle, or sorry, not RPGLE, SQL RPGLE on there, save it and close it. What I can do now is now again, I could either just run the staged stuff. So I'll just stage both of those files, deploy and build stage changes, and then it should run the action. And now if I go back and look over here, there's my hello vid program, which I built from my local machine. I didn't do anything else. It was all the code that was running locally. So I can call that. If I do call, or eventually, sorry, add libel Barry and add libel sample, we'll talk about sample in a moment. Then I can do call hello vid, and it will display, oh, wrong button. Sorry, I'm on my Mac keyboard, it's kind of tedious. So it'll be F10, Shift F6, and there's my hello world that I put on there. Nonetheless, I'm able to write code locally and it works as expected. It's really cool. Let me commit my change, add new hello vid program. Excellent. So we've really done it. I mean, I didn't show you the depths program. So if I do call depths, it's a display file, and now I can go in, look at all the departments that are available, take a 5 and look at the employees that are inside of that department. It's a really basic program, doesn't do a lot. That's really it. But now we're on to, the next thing that I wanted to show you. Why do I keep pressing the wrong button? Come on now. It's F3 to exit. There we go. Now, the next thing that I want to show you is actually kind of just linting and having clean code. So cool, we can write and build code locally and test it on the IBM, which is neat. Now I want to show you the linter. So I have the source code open, and I'm going to just open the lint configuration. So let's go Command-Shift-P on a Mac, or F1 on Windows, or F1 on Mac if you have function keys. And I'm going to say open lint configuration. You can put that in the command palette and it will show up. And it just creates this default file, which is nice. Now, these are the default configurations, and you can change whichever ones you want. For example, if I look at employees, it's probably going to complain because I have data structures that aren't qualified. That's one of the lint rules that I have set up. And I'm going to turn that off because that's part of the nature of development in this standard here. Nonetheless, what we'll do now is quite simply, I guess we'll fix a bunch of these issues. Let me close that for the time being. And I guess what we can do is I'm going to show you that the linter can solve at least some of the issues. So for example, variable name casing is another condition that I have set up. So if I look on the command palette and look for fix all auto fixable problems, you'll notice that it just made the little change there and actually updated it, which is nice. Did I actually turn off the right rule? No, I didn't. That should be true. Qualified trick should be false. There we go. Let's close that. And then those lint rules will go away. Very good. And then you'll notice that the last issue that we have is just the use of constants over and over again. So what I can do, of course, is make a constant, call it all good. And of course, the value is going to be all zeros. And then replace the use of all good there, like so. And we're looking good, which is great. Very nice indeed. That was really easy. So nonetheless, what I'm going to try and do now is actually compile the changes that I just made. So of course I can do Command E, and I'm just going to do all of the stuff because I don't really care. It's okay. It's a small folder. And in that case, it was actually incorrect because, well, this isn't correct. I've used declare standalone when it should actually be declare constant, like so. So I fixed my issue. Now let's run it again. Deploy and build, all changes. And there we go. That time it actually worked, and it looks like the linter is just complaining about some things now. So what's this? Constants must be in uppercase. Okay, I'll just do the quick fix on that. That looks good. And then actually it's going to complain in other places because the variable names don't match. But I can just do the auto fix on those and they'll go away. Really cool. Now let's do one more thing. Let's take a look at depths. And you'll notice here that this is not a free format program. This is, it's got a fixed format fspec and it has this file info. So let's convert it to free format. I'm going to use a different extension here. I'm going to take a look and it's called RPGLE free right there. It's a fantastic extension. And what this allows me to do is if I select a piece of code, right click, convert to free format. Now I have a free format definition. It's a really great piece of work. Now I also want to convert file info, but I only use function key from it, so I'm just going to get rid of everything else but that, and then I'll select it and I'll right click and I'll convert to free format, and now we have the free format version. And now really the issue is I want the indentation to be correct, because now I've got this at the different spaces and these are different spaces up here. So what I'm going to do is just stick **free in there and then have the linter complain. So then I can just fix all auto fixable problems and have it solve all of them for me. And of course it has the same issue as before where the constants are used, but I'm not going to worry about that right now. And I'm going to save it. And then I'm going to do deploy and build, all changes. It's going to deploy and build, and it failed that time. It looks like we have an issue. Department is not defined for reason code 1. So why is that, I wonder? Well, that's because this fixed format comment was not removed. That's okay, I can remove it myself. And then that's going to complain, so I'll fix that too. I'll save it, and I will compile again, deploy and build, all the changes. Deployment finished and the build finished, and it looks great. Now, just to show you that it does still work, let me pull open my 5250 again. I probably shouldn't have closed it in the first place. And if I sign in, and I do add level Barry and add level sample, call depths, and it's looking good as ever. So I can do a 5 and F12 to go back. It's looking excellent. Very happy with that indeed. And I'm pressing the wrong function key again. Very good at that. And there we go. That's really everything. We did a lot of stuff in this video. It turned out to be a lot longer than I was expecting, but I'm very happy about that. Let me know what you think. Thanks a lot.